Okay. Alright, okay, so we start with question number 7. Okay, so number 7, a particle move in horizontal circle of radius 15 centimeter inside an inverted smooth hollow sphere. Alright, so this one, you have two radius given. Okay, so ada dua radius yang diberikan dalam soalan. The first one is 30 centimeter. The second one is 15 centimeter. So you need to really understand. Okay, so 30 centimeter is the radius of the hemisphere. Okay, while 15 centimeter is the circular motion, okay, by the ball. Okay, so dekat sini you kena make sure lah, jangan tersalah radius. Okay, so the first one is sketch a free body diagram showing the forces acting on the object. So saya dah tunjukkan last time dalam kelas. So since you have the surface over here, okay, so sangat macam ni. So it means that you're gonna have a normal force something like this. Okay, normal force ataupun reaction force, because we know that normal force must perpendicular to the surface. Okay, alright, and then macam biasa you akan ada weight W ke bawah. So after all, your free body diagram will be something like this. Okay, so yang ni saya rasa tak ada masalah. And then calculate the speed of the particle. So dia minta speed. So bila ada perkataan speed, radius, maksudnya you kena tahu relatekan centripetal force dengan force yang berkaitan lah. Okay, kena tentukan dia dalam komponen X ke dalam komponen Y. So kita completekan kita punya free body diagram. Okay, kita ada paksi X and Y over here. So tell me, what is the direction of centripetal force over here? Kemana direction dia?
To the left.
To the left, very good. So you ada centripetal force in this direction ataupun AC ataupun FC, you boleh tulis Alright, so perhatikan saya tak letakkan anak panah tu berada dalam paksi. Okay, because centripetal force is provided by other force. Okay, yang tu yang kita kena tentukan. Alright, so now we're gonna start with the FC macam biasa is equals to mv square over r. Okay, terus tulis mv square over r lah sebab soalan minta speed. Okay, and then the FC in X component, it means that the FC provided by force in X component. So summation of Fx equals to mv square over r. Okay, now so we have normal force between X and Y component. So maksudnya kita kena resolve lah macam biasa. But the problem is there's no angle over here. So kita kena cari. Macam mana nak cari angle? Cara dia adalah you kena cari triangle yang ada dalam gambar aja. Okay, so in this case relatekan dengan normal force kita lah. Yang ni direction normal force tadi tu kan. Alright. So the information given over here, this one is 15 centimeter obviously. Alright, the hypotenuse over here nilai dia berapa? Saya tunjukkan semula triangle kita berada di sini. This one. Okay, so saya keluarkan dah. Saya letak kat sini 15 cm. So the hypotenuse of the triangle tu nilai dia berapa?
30
cm. 30, yes, 30 cm. Okay, alright, because we know that the radius of the hemisphere is 30 cm. It means daripada mana-mana surface pergi ke center, tak kisahlah, nilai dia akan sentiasa 30 cm. Okay, sebab dia adalah radius. You kena ingat balik, radius ni adalah jejari, okay, maksudnya jarak daripada center pergi ke surface of the sphere. Okay, kalau circle daripada circumference ke center. Alright, so this one dekat mana pun kedudukan bola ni, okay, so jaraknya daripada surface pergi ke center is 30 cm, is the radius lah. So you have 30 cm over here. Right, so now kita nak cari angle dekat sini. Okay, the theta over here. So we have adjacent and hypotenuse. So it means that you can use equation untuk cari angle cos theta equals with 15 divided by 30. Okay, so you akan dapatlah theta sama dengan berapa. So you can put over here theta. Alright, so bila dah ada theta, tak ada masalah dah. So next, macam biasa, so summation of fx, we have n cos theta equals to mv square over r. Okay, so nak selesaikan masih lagi ada masalah. Kita tak tahu nilai n. So macam mana nak dapatkan nilai n? What we can do? Kat mana nak dapatkan n ni? Satu lagi equation.
Guna y component.
Yes, very good. Summation of fy equals to 0. Okay. So ini benda kita belajar daripada chapter 4. Usually kalau you tak dapat selesaikan dengan x component, you akan pergi kepada y component. Okay, sama juga kalau you start with the y component tak boleh selesai, then you go for x component. So we have summation of fy equals to 0 because we know the object, okay, the particle over here, dia tak bergerak atas dan bawah. Okay, and we have the direction of centripetal force in x component. So maksudnya summation of fy equals to 0. So what we have in y component is n sin theta. Okay, n sin theta, yang ni kita resolvekan, minus with w equals to 0. So it means n is equals with mg, okay, saya convert terus w tadi, divided by sin theta. Okay, so now we have the value of n, so substitute balik semula dekat sini. So you have mg over sin theta, okay, times with cos theta equals to mv square over r. Alright, so sebab tu soalan dekat sini dia tak bagi pun mass because you can cancel out the mass kiri dan kanan over here. Alright, so boleh masukkan angle macam biasa, then you can calculate the value of velocity dekat sini, okay, with the unit ms -1. Alright, r over here, what is the value that we should substitute? R dekat situ r apa?
0.15.
Yes, 0.15. Okay, make sure in SI unit lah. So R dekat sini berbalik kepada radius of the circular motion because dia datang daripada equation Fc equals to mv squared over R. Okay, so yang kat sini lah you kena perhatikan betul-betul. Nilai R yang dia nak tu nilai R yang mana satu. Okay, alright. So ada soalan tak yang dekat sini? Boleh buat? Boleh faham tak?
Boleh.
Boleh,
ulang balik tak?
Yes.
R dia tu dapat mana?
Okay, R this one, okay, so yang ni equals to 15 cm ataupun 0.1 cm lah, convert dalam SI unit. Alright, so R dekat sini, R this one adalah radius of the circular motion. So circular motion of the ball dekat sini. Okay, this is the circular motion of the ball. Alright, so we have to use the radius of the circular motion, bukan radius of the hemisphere.
Okay.
Okay, jelas Alright.